Programming Throwdown, episode 122, Building Conversational AIs with Joe Bradley. Take it away, Jason.
Hey, everybody. So one of my most fond memories is playing this game, this really esoteric game called Essex, which I think is named after a place in the UK. But it was this game where it was like Zork, if people are familiar with that, but it was one of these text-based story games where you would type, go north, go west. And the thing that amazed me, I mean, I was maybe 7 or 8 years old. The thing that amazed me was that I felt like I could just say anything to these computer players and that they would respond with really interesting things. And it ran on a single floppy disk. And so, honestly, to this day, it kind of blows my mind. But as a child, it just completely blew my mind. I mean, I was wondering if there was a real person somehow involved, like, in real time. And I've always been really interested in conversational AI. And I feel like we're all just exceptionally lucky to have Joe Bradley here, who's the chief scientist at LivePerson, who is an expert in this field and really going to talk to us about how conversational AI kind of works, a bit of the history behind it, and how kind of LivePerson and other folks do it today. So thanks so much for coming on the show, Joe.
Hey, thanks for having me. I'm really excited to be here, and even more excited about the fact that you just brought up Zork. For me, that was the one. It wasn't the the Essex or that I didn't know about, but yeah, I spent hours doing that as a kid. And it's funny too. I have children myself now, and I see them. Just last week I went downstairs, and they're not playing Zork, right? But they're playing the equivalent on the Amazon device, on the Alexa. Somebody's coded up a little like exploration game, and now they're talking to that. It's essentially the same interface, just with the voice instead of text, and it's still fun for them, which I think is like really interesting, even in this age of like, hey, does everything have to be these like cool looking graphics, and what's the UX got to be like? There's still something powerful about just talking to a machine like you can like you want to, and in a way that's easy, in a way that's natural for you, and then having the thing respond and tell you a story. Right? That's cool still.
Yeah, I think that, when it's abstract like that, you kind of, your mind fills in those gaps and fills them in a way that's like really interesting and pleasing to you, right? And so that's kind of the I think, who's the Scott McCloud, I want to say, if I'm getting that right, but he wrote a book about understanding comics. And he explains that the reason why comics are originally they're meant to be written really quickly, but another reason why comics work so well as a medium is that they're so abstract that when you watch, for example, Dilbert, you kind of put yourself into Dilbert, versus if Dilbert was photorealistic, you wouldn't really be able to do that as easily. And so yeah, games like Zork and Essex they do that. Your mind fills in all those gaps.
Yeah, they hit this spot for us that's like, if you think about how evolved we are to have conversation, right? And how important conversation is to us as human beings, right? It's the fundamental way in which, we created efficiency, resources, wealth, right? All the things that we have today are founded on the abstractions that make conversations possible, right? Language itself. And then the ability to have those in a two-way or multi-way dialogue, so that you can build more than just what's inside your own mind, right? So I think in some ways it's like surprising when I look at my kids playing Zork on that device, and in other ways it's it's like, oh no, wait, we're evolved to do this. Like, this is what we want. We want to build stories, and now it's just it's kind of interesting that the last 30, 40 years we've begun to be able to do that with inanimate objects, right? And that like we sort of know and we sort of don't care, and it's sort of still fun.
Yeah, it's amazing. So I want to dive into. I would love to know how Zork works, and then also fast forwarding the future. But before we get into the tech side of it, what is kind of your background and what led you to building conversational AI at LivePerson? What's that story like?
Yeah, it's a little. I don't want to say topsy turvy, because it's not a bad story in my mind, but it's definitely a little all over the place. So if you go back far enough, you start getting to like an interest in opera singing, and and a major in English literature and a whole bunch of stuff that like doesn't fit very well with where I am today, at least not in most people's minds. So for me, it's like I tend to find like have moments of like 5-year kind of moments in my life where I get really, really passionate about something, and those end up like being a stepping stone to kind of somewhere else. And so when I was, out of undergraduate school and starting, working as a classroom teacher in San Francisco, I got reminded about how, I was teaching math and science to seventh graders, which is, by the way, the hardest job I've ever done by a factor of 10.
It sounds difficult. I remember middle school as being one of the hardest points. I've only ever been in one fist fight in my entire life, other than martial arts, which doesn't count. And it was in middle school because I was playing basketball and I blocked somebody because I'm very tall, but I'm not particularly athletic, but I do have the height. And I blocked someone and he was upset. And actually, I wouldn't really call it a fist fight. He just punched me in the face. And I was really upset about that. But I think middle school is an extremely challenging age. And, Patrick and I also have kids. And so that's an age I'm not really looking forward to, but we'll have to get through it.
Yeah, I mean, a couple like I will not forget the day one of my students, she was this probably about 6 foot tall, 12-year-old girl, looked at me and she said, I was like just getting started. I was like like I said, it was this undergrad English major who was like, I want to go be helpful. I want to go do something meaningful in a city. And I just moved to San Francisco, so I got this job teaching. And I was a couple months in. I was not good at it yet. I hadn't figured it out. And she looks up at me and she says, "Hey, Mr. Bradley, this class is just like WWF SmackDown." And I hung my head that day. Like it was not like because she was right. I was like, wow, this is not good. And I mean, thankfully, the institution of public school in San Francisco was very helpful. They brought me this mentor teacher who had all this knowledge about how to work with kids. It's really just like simple things that you'd never think of, right? Like don't talk about what one kid isn't doing well. Stand next to them and talk to the kid who's doing it right and praise them. And then the other kid's going to suddenly look up and want to do the right thing. All these sort of tricks of the trade that were just like life changing for me. But anyway, yeah. So to get back to your question, I sort of rediscovered a love I had for math. I'd studied it a bit in college. And I was doing teacher training on, adding negative numbers or something like that. How do you teach a 12-year-old how to do that? And what are good visualizations and all these things? And it just brought back to me like, oh man, like I had so many questions and so much farther I wanted to take that led me back to school. And so I went to school for a master's degree in mathematics at SF State University, San Francisco State University, part of the Cal State system, which I think deserves a plug because I feel extremely fortunate to have been able to go get an advanced degree in mathematics and pay something at the time like $800 a semester to do it.
Oh my gosh, amazing.
Yeah. It's more now. I know it's more now, but I think it's still a pretty good deal. And back then it's, that's life-changing stuff, right? Like these are cultural institutions or, that we have built for ourselves that affect people's progress in life dramatically. And so that was I think that's a special institution. For me, that was a special time. And that kind of led into physics, right? Like I was doing the math. And I was like, well, I want to do something with this math. As fun as the abstraction is, I've always kind of been attracted to abstraction. I want it to be good for something. So I ended up going up to University of Washington, moving up to Seattle and working on a PhD in physics. And that kind of led me to, a lot, obviously more applied mathematics, obviously beginning to work in statistics much more deeply because I ended up doing a bunch of experimental work and, in addition to turning bolts and building instruments and firing x-rays and lasers at stuff, like you've got to go do the data analysis. And we started to think that there were some, more advanced statistical analyses that would help us understand convolutions of data and all these things so that started to filter in. And as I became a full-time scientist, I just found a lot more passion for that when I was working at the national labs. And it was one like sort of component of a larger decision that led me to change tracks and end up kind of in the industry I'm in today. And that was kind of by way of Amazon, right? So I sent all these resumes out because I was interested in, I was going to get into machine learning. It's a live field. It's new. I think I have been reading the papers. I've been like, this is a fun time, as opposed to physics, which is like hundreds of years old and everything's super sub-disciplined and, very, very narrow and very, very tight. And it takes a long time to approach anything state of the art. I was like, machine learning, well, this is different, right? This is new. This is live. You can learn it, not quickly. It's not easy. I don't mean to say that, but you can get to the front of the discipline, much more effectively. And I think there's just a lot of like ways in which knowledge is shared in the ML community, and they're pioneering like this sort of academic research and shared code and all these things that like wasn't really happening in physics. Though that's starting to now.
Yeah, I think you're seeing the same thing with economics. So I've always been really interested in economics, and what you're seeing is ML start, because ultimately economics is especially microeconomics is ultimately about people and the way they behave. And so you need to, it's statistical by nature because we're not going to have a human brain processor. So we're going to be estimating that. And so yeah, you're seeing ML make a ton of strides in that field. And I think at some point ML will diffuse and just be a part of all of these fields. And ML, as we know it now, will become more of like a core, how do we make the learning really well? But I think we'll get to the point where maybe even conversational AI won't even be ML. It might be part of like a speech understanding or something like that.
Yeah, I think that's right. I mean, I think if you really back up and think about what machine learning is, and even if you think about that in the context of the neural nets, what are they really doing? They're taking these qualitatively different kind of problems because they have such a high degree of dimensionality and such a weird set of correlations across the variables that describe them. And then they're trying to find these like really, really useful local potential minimum in them, right? Like these really, really useful like solutions, whether or not they're, the perfect or the global, and I mean, I know there's a whole branch of ML that's devoted to finding, convex problems and all that stuff, right? Like, but I think the way the field's evolving is we realize that like real problems are like way too dimensionally complex to solve in those exact ways, or to even approximate towards those global solutions. And we're all just okay with sort of these local solutions. But that's going to like any field that has anything approximating a real problem, and most good fields do, it's going to benefit from that basic approach, I think. I mean, it obviously creates new problems of like, well, how do you know if your answer is good enough, and what does good enough mean? But for real problems, like those are, questions you just have to cope with.
Yeah. So you don't have a CS degree, correct?
No, I'm a research self-taught programmer at start anyway, and I got a little bit of a crash course about how bad a programmer that made me when I worked at Amazon, for sure.
So yeah, let's back up a tiny bit. How did you interview at Amazon? Because this is something we get asked constantly. Someone says I have a background in physics, or I have a background in economics, or I have a background in chemical engineering, and I want to interview at Amazon. How did you get that right mindset to be able to do that?
Yeah, so it was a case of like there's a little bit of luck in there, but I also was intentional about how I did it. So I can't claim this will always work, but I think it was a relatively smart strategy. So I'll explain it a little bit. So I did, as I said, I sent out a bunch of resumes and heard very little back. Right, I was like, "Who's this?" Basically, I think people would see that resume and be like, "Who's this national lab physicist like doing X-ray experiments?" Like, yeah, get this thing off my desk was kind of an easy response for most sane humans to have.
Or sadly, it's even an AI, so a person didn't even have an opportunity to see the potential, right?
Could be. I mean, we definitely, our recruiters at LivePerson, right? They look at a lot of resumes still, but I think there's search queries. You got to be smart about how you set up your resume. You want to have the right search terms on it. All this stuff, like you got to get a human looking at it.
That's true. Yep.
And then what I did is I wrote, even though it wasn't asked for or common at the time, and it's probably less so now, I wrote what I thought was a thoughtful cover letter explaining what the heck I was doing there and why the heck I thought this made sense. And so I tried to break down my experience. In particular, I spent, like a while crafting this paragraph about how I had been doing these experiments in a national lab context where we'd go in and we'd have limited X-ray beam time, and we'd sit down and we'd have, 24 hours to conduct the experiment. And we had to be very thoughtful about how we planned it. We had to be very good at troubleshooting problems. We had to really deliver in this very tight, constrained environment, or we were not going to be successful. And my pitch was like, look at what I've delivered. Here's the output of these publications, this advance in this field. Right. So I didn't want to make that like a 4-page monologue, right? That was like, had to whittle that down to 4 or 5 good sentences. And there was some recruiter, I knew her at one point, and I've forgotten her name now because it's been quite a while. It'll probably come to me after the call. But there was this woman who was a recruiter who saw it and read it and just thought, like, she was just like, I think this could work, right? I think we should talk to this guy. And I did talk to her. As I said, I talked to her, later after I joined Amazon. I had a couple of conversations with her, and she kind of relayed this to me that reading some of that text was an important part in her decision making. It wasn't the only thing, of course, but I think that's smart to do. I think, obviously you got to get past the sort of AI or the querying, all that stuff. But then you should remember there's a human on the other end of this, and they need me to make sense. If I'm not coming from what they see and what they expect, they need me to make sense of why my experience fits and how that story should go together. We're all narrative machines in the end, right? So they need me to give them that narrative and take the time and the space in your resume or in a cover letter, however you do it, to make sure that story is told and make sure that story is clear, but also make sure it's like super concise and tight. Like, I can't make that point strongly enough. If you write well, that also says something, and you don't have a lot of attention. You should imagine you've got 30 seconds of attention if you're lucky. How do I tell that story that quick?
Yeah, absolutely. And so when you went to Amazon, were you working on conversational AI on day one, or is that something that a team that you transitioned to later?
So I ended up doing, a number of natural language applications at Amazon and at Nike subsequently, right? A lot of it related to how people are, like what kinds of interests they have in products, what's useful to them about products, things like that, what their website experience was like, a lot of analysis of text. And I started building conversational AI with some of the experts we have at LivePerson. That my real first foray into conversational AI was with LivePerson. Like, that's where I began to
Okay.
build. And we've brought on a lot of people. So I consider myself a little bit more of a generalist. My background's more statistics, machine learning, et cetera. I obviously have learned a lot about conversational AI in the last 3-4 years working at LP. But we, of course, have people that have spent their whole careers on it as well.
Got it. Okay. So if you could kind of lay the land for us here. So there's natural language processing, which I think, and please correct me here, is an umbrella that covers, let's say, translation, maybe embeddings or semantic understandings of language. And conversational AI would also be under that umbrella of NLP. Is that correct?
Yeah, I think that most people would agree with that. It's like most designations like this, where there's always, somebody who feels like, no, my semantic description of this field is more accurate.
Right. Yeah.
But yeah, I mean, by and large, NLP is like a big box, and inside that box goes like the science of processing natural language, right? Like, kind of quite literally. And conversational AI is a kind of processing of natural language. It's a very specific one, obviously a very important one, we think. But yeah, I think that's fair. You also have, and inside of conversational AI and or inside of natural language processing, you have the subfield of natural language understanding, right? Which is again very important to conversational AI, and that's sort of this. Again, it's another one of these ones that like is what it says it is, right? So it is the science of trying to, use algorithms to create, what do we mean by understanding? Essentially, a structured form of or a structured interpretation of words of natural language that we use. Go from this like unstructured text, go from that format and sort of begin to categorize and and adorn these natural language utterances with like things that are meaningful to us in the abstract.
Yeah, that makes sense. And then in the other direction, then you're talking about natural language generation, where you say, I have this structure, this JSON, which has this information that I know somebody needs. The movie starts at this time, or this is when your pizza order is ready, and it has to get turned into text that people would it would feel natural to them.
That's right. Yeah, you've got that, the sort of semantic box of metadata, however you get it, wherever that arose from. Some system did some processing and said like, here's the semantics or the meaning of what I want you to say, machine. And then the NLG portion, like basically input is that, output is spoken language or written language or whatever it is. The other piece in the middle there that, people can slice and dice in different ways, and it's still a very open sort of research question, is really around all the dialogue management, right? So you have the understanding, you have the text coming in, or the words coming in. Let's assume it's just written text, because then you can always kind of model the speech and the voice side as at the other end of this pipeline. So you have text coming in, you have this understanding capability whose job it is to, decide what it means, what it means, what was said, or what was said means, I guess is the best way to say that.
Mm-hmm.
And then that comes in a structure now that interacts with the dialogue manager, or, again, that can kind of be a few pieces, but broadly speaking, dialogue manager's job is to take that information, understand it in the context of, what's going on in the conversation up until now. And some managers do a lot of that, and some managers do none of that. But logically, that's the responsibility of this piece of the system. And then to turn that into a next action. And then that next action gets passed out as like one element of that next action. There may be lots of things that happen, right? It may go call an API and check your balance for your bank or whatever it is. But it's also going to, result very likely, or most of the time, in wanting to send you some text back. And so, in a system that has a decoupled NLG component, as you mentioned before, it will send back now this metadata blob, and the NLG's job will be to go and turn that into language, and thus kind of conversation, right? So those, I think, are the, like, in big animal letters, so to speak.
Mm-hmm.
Those are kind of the big blocks here, as far as a conversational AI system goes.
Yeah, that makes sense. So I think, if I remember correctly, Zork didn't have conversation. It was more of like a pick up sword, hit troll. I mean, it's been a long time since I played that, but there have been interactive fictions with conversation from a long time ago, like this SX one. I'm sure there are other ones of its era. And trying to unpack it today, I think what they were doing is they probably had some WordNet ontology, on the disk. And so I think maybe what they were doing was they were taking your sentence of what you told the avatar, and they were looking at each word, and they were maybe traversing up this word net. So just a bit of background for folks. WordNet is basically a tree of the English language, and it's been around for a very long time. So you can imagine, I think the root word is entity, if I remember correctly. So everything is a child of entity. And there's objects and abstractions. So if you were to take like happy would be an emotion, which is an abstraction, which is an entity. And so you could kind of go up this chain. And so if I ask this avatar in this game from the 1980s, are you happy, or are you I don't know, I guess elated, or something like that? What they would do is they would go up this WordNet chain, and then they probably by hand kind of thought about what to do if they get these really high level words, and they were able to kind of cover a pretty broad range there. And so my guess is there's something like that, and they were just pulling out individual words, and then if they see that word, then they know, okay, this person asked me about the key, or the person asked me about being sad. So start the sad narrative, where this person can go on this quest to make me not sad anymore, things like that.
Yeah, no, I think you described then, like, a lot of, what natural language understanding, was and kind of had to be for a long time, right? And like that, there were sort of techniques like that, a lot of like different, very ornate ways of dealing with language, because language is exceptionally complicated, and dialogue even more so, right? Like just the understanding piece of this has been a extremely important and huge research effort for a long time, right? And I think a lot of times we sort of claim it's a lot more closed down today than it really is. Like, that's sort of something interesting to talk about too, is like, how good are we at natural language understanding? How good are we at dialogue handling? And my answer is, we're not as good as we think we are, neither in the academic nor in the professional context. And like, part of doing this work well is is beginning with that recognition, and then realizing that we have to build, tools and capabilities to help us, get to the level set where many of us kind of already believe we are. And I think there's a lot of reasons for that. There's hype in both the professional and the academic context, which will also be interesting to talk about. But you do see, material advances that are very, very meaningful in the same way that we saw for computer vision, starting back in 2006, the beginning of a neural net approach and the first kind of, early auto encoders, right? That start to change that problem around, and then the development of convolutional neural networks that, where the network sort of satisfies some of the symmetries of the system itself, and that allows it to work really well, and kind of like reshape the functional capacity of these networks well enough so that they can, they make really good guesses at these approximate local minima we were talking about before. You start to see some of that happen in the last 5 to 10 years in the natural language space. But it's hard. It's frankly harder, in my opinion, because like I can talk about what the symmetries of physical space are, right? Like, move left, move right, move up, move down, rotate, reflect.
Yeah, I mean, if you're training something to like play chess or something, and you flip the board, on its axis, your strategy doesn't have to change, or it's a mirror strategy, and so you could even just directly, hack that into the system, and now it only has to learn half as much. But for language, it's totally unclear what that symmetry is.
Well, yeah, I mean, what is it? Like a symmetry in language is like a synonym or an antonym,
Yeah, right.
right? And so how do you teach a computer to understand that, right? And I think what if you start to break the problems apart like that, like it starts to become clear, or at least you can make a good intuitive explanation for why, attention mechanisms are really meaningful, and why the neural nets for some of these modern applications have developed the way that they have, because they're trying to solve some of these symmetry problems in the same way that you and I do. Like, words through context, right? And we're really good at recognizing like which elements of context like actually impact each other, even in like a long form piece of text. So I think we've started to learn some of that, and I think obviously there's been, a lot of major advances recently, separating out like what's kind of hype, or what it means to have advanced with something like a GPT-3, for example, what that really is good at versus what it's really not good at. I think that's actually very hard for us, because in some ways, because of the nature of what it's doing. It's producing, such compelling text on its own that it's hard for us not to imagine, like a some kind of Wizard of Oz entity back there that's like all knowing, that's doing that, and really tease it out.
Yeah, I thought the there's one research. I'm sure it's a whole body of research, but I thought it was really fascinating. I can't remember if it's using GANs or transformers. I don't totally remember, but it would caption an image. So you would give it an image, and what would come out would be, a girl is sitting on a red swing, talking to a boy near a tree. And I thought that was so cool. I mean, when I saw that, that blew my mind, and I felt like that. I mean, well, actually, it would be great to know for your opinion. I mean, it could be hype because I don't know the tech that well, but I feel like we reached a milestone when I saw that paper.
No, I 100% agree with you. So the automatic image captioning is an example. It's almost an anti-example of like GPT in some ways, because what that's doing, and there's a long way to go there. I mean, it's not gonna approximate, really complex tasks. It's not gonna handle really complex tasks the way that like you and I, with the eloquence that you and I would, or any human. But it did something fundamentally different, right? Which is to do that research, and a lot of this came out of Google, in sort of the image search space. Like there's, I think, a lot of genesis there. But to do that work well, what had to happen is you had to develop a shared mathematical representation of the visual image and of the text, right? And so the way you typically train models like this, I mean, it's been a while since I looked at this research, so this could have changed. But the last time I looked at it, which was several years ago, the way you typically train models like that is you have like, two vectors, one representing the sort of vectorized form of the speech or the language, one representing the vectorized form of the image, and then you're trying to optimize their inner product, right? So they're getting closer and closer together.
Yeah, what just to double click on that. So we had an episode. Our last episode was with the CEO of Pinecone, and Pinecone is a vector similarity database. And we talked about how you can take sort of any classification problem, or even in an unsupervised or self-supervised way, you can kind of take a chunk of data, and you can create a embedding or a very relatively low dimensional representation of that. And what Joe's here's talking about is you can actually do this with two different media and try to join them together, when you've seen them together on the same website, or if you have a hand curated set, and now you end up with two things that are projected into the same space, and then you can go backwards with one of them.
Yeah, that's exactly right. Sorry for not giving a little more background there, but to me that's fascinating because what it's like a step in teaching a system to have a multimodal representation of reality, right? So now the image and the text are in a shared space, as you say, a shared mathematical space, a shared semantic space, which is how you and I work, right? Like we don't differentiate, like the concept of red dress, the words and the picture of that in a physical red dress, that's all, those are all of a piece for us, right? Those are all related, like obviously very strongly related, it's just different representations of the same fundamental object. So I think that, and that's very much not what like GPT did. And don't get me wrong, I'm not trying to talk trash about GPT. I think it's an amazing advancement. In some ways, I think we should think of these big language models as like national resources that we're building, because they literally take as much power. Like you measure the power required to train one of these things like in units of Hoover Dam, like that kind of that's actually a reasonable scale. Like I forget how many like Hoover Dam days it is to train GPT, but it's not like 0.0005 or anything. It's like a real number.
Yep. And you can transfer learn off of it. So it really is. I think that's a beautiful way of looking at it. It really is like a national treasure that we've all spent a ton of time and energy curating, and now everyone can benefit.
Yeah, with a whole bunch of infrastructure required to do it, right? You can't go
Yep.
do that without the data centers. You can't go do that without industrial strength power lines going everywhere, right? Yada yada yada.
Yep.
But GPT is different, right? It's what it's trained on is not, and it's not trying to find this like multimodal representation, right? It's trained on basically most of the text of the internet, right? So it's
Yep.
it's a window into what for us is like a projection of reality onto text, right? That is GPT's reality, right? That's what it knows, right? Which is why, and we start to think about it like that, like the ways in which the model's amazing and the ways in which the model's confusing, at least to me, start to make a little bit more sense, right? You can ask, so you think, all right, if I train this model on this and I ask it who the president of the United States is, and in 1815, it's going to give me a good answer because it's got all these good relations. It's got a bunch of text to work with. It could tell it that answer. Obviously, it's an amazing advance that we're able to synthesize that into a system that can make the inference. But then it's also like if you go and ask it who was the president in 1705, right, before the country was instantiated, it'll give you a reasonable answer of a person who's kind of sort of presidential. Right, it might give you like Ben Franklin or whoever.
Yeah.
That's probably too early for Ben Franklin, but yeah, you can go and sort of trick it with these questions and these premises, and it doesn't do a great job, without some further prompting and some further help in like understanding that question doesn't make sense in that context, because it's this really big and sophisticated association machine that doesn't have larger political context, like doesn't really understand what it means in the same way that you and I do for some of these historical events to have taken place. It's really doing much more associative work, and a lot of that's that thin layer of like it's just on this like if language is kind of a membrane of our reality, right? It's stuck on that membrane, and it can't escape.
Yep. Yeah, I think so. Correct me if I'm wrong. GPT-3 is trained such that they take like a string of n words, and then they try and predict the next word, the n plus one word. And so what you end up with is now you can give GPT-3 a sentence or a paragraph or what have you. It will generate the next word that it feels like belongs there.
So what you just described is fundamentally what a language model is, and GPT-3 is a language model, right? So what, like mathematically, the definition of a language model is like given n words, predict the n plus first, and however you get there, however you want to do that, that could be a set of rules in the background, that could be whatever. Like some algorithms got to do that job, and then once you have the reason that's an important construct in the field is that once you have that, it unlocks all these other things, right? It's like now I can ask questions, I can turn that prediction and the underlying representations of the text and the knowledge that fuel it into really, all the many of the applications that we care about today, right? So it's kind of a building block. And so GPT, and you train these language models in different ways. Like you don't always train it, specifically train it only for that, with that task, right? Like that is the mathematical sort of fundamental definition of what task a language model has to perform. But there's lots of transfer learning and
Okay.
like different ways you get the model to be good at doing that. And then of course on the other side, there's a bunch of applications you go and turn on for it. So, but a lot of the sort of self-supervised aspect of training language models is really about making adjudications of how good or how well a word fits in its context.
And the nice thing about something like GPT-3 is that although you have to use, Hoover Dam days worth of energy, you don't have to do any manual labeling because it's self-supervised. It's just scanning this data from the internet, and it's trying to learn the rhythm of this data, and it can just see right away, did I predict this word correctly or not, without any human intervention.
Yeah, no, that's why it's powerful, and that's also why it's limited. Right? There's only so much you can learn that way, but there's a lot you can learn that way. And as a baseline for learning other things, it's kind of the best one we've got right now. That's why people are so excited about it, and it's pretty cool. I mean, we didn't have anything like this 15 years ago, and now we have models that can tell us stories that really are rapturous in their detail, right? I think it was brilliant to bring out GPT-3 with the article that it wrote about itself, right? Is
Yeah,
like
right.
an amazing way to illustrate that, hey guys, we're on to something new here. Like we're in Star Trek territory, kind of, sort of, a little bit.
Yeah, so bringing us back down to earth, in my opinion, I feel like there's two big pieces that are missing, and there's probably a lot more, but I'd love to get your take on it. I think one piece that's missing is getting uncertainty estimations about from really any of these models. And so, to your point, to where they can, you say, what is the American president in 59 BC? The model should just say, well, like, I'm not confident about anything here, right? And then the second point is having some kind of symbolic understanding, to where it can understand, in a modular way, it can understand and compartmentalize America as a concept and when that concept started. And you can use like some first order predicate logic to say, well, the question is invalid because of these sort of symbols. I think that we've gone to this sort of this embedding soup, and because of that we've lost the ability to think about things and reason about things in like a logical, methodical, search kind of based way. And I feel like those are the two, at least in my opinion, the two big missing pieces.
Yeah, they're both really, really interesting, and they're great points. Let me try and like at least take on one of them. Maybe we'll get to both because I love to talk about both. So as far as like the logic point that you make, so look, I agree with both your points. First of all, I think
Mhm.
those things are missing. I think the logical element or the higher order logic, we don't know how to teach computers to do well. I personally don't think the answer is, at least not in as flexible a way as you and I do it when we sort of think through the universe as we do. I don't think the answer is to construct a kind of symbology of it, right? That like then these inferences are going to like be mapped into, and then there'll be some kind of logical computation that happens on the symbology, and then that's going to go back to the embedding space and like give it a different. I actually don't think that'll work. I mean, I could be wrong. What do I know? I'm just one guy. But the reason I think that space of like what are the constructs and what are the abstractions that we use to make decisions at the higher order logic is itself just as complicated as the reality it's trying to simplify, right? In terms of like the relations between the constructs and the boundaries. A lot of things are complicated because the boundaries around what is this construct versus, not like what's in the set and what's not in the set are just hard questions. And so I think in the end, we're going to have to find a way to teach a machine to construct representations like that for itself, right? But there is going to have to be some notion or some parallel process that serves the same function of the logical hierarchies that you and I would use. And like, we teach humans how to do that, right? And sometimes, when you get into like deep political disagreements, like sometimes at the root of that is just kind of a misalignment of some of these definitions of categories.
I think just to riff on that, like one thing that I think paves a way is the MuZero. I don't know if you've been following MuZero from DeepMind, but DeepMind, their claim to fame, or their initial claim to fame, was beating the world master at Go. So Go is this board game. It's just a lot more complicated in terms of branching and other stuff than chess. And they were able to beat Lisa Dahl, and now a computer is the world Go champion. But they didn't stop there. The next thing they did is they built something called AlphaZero, and AlphaZero removed all of the Go specific logic, and it treated it as just a field of. Now they did have to do some feature engineering, right? So you can imagine, Go has just white and black stones. Chess doesn't. Chess has a whole bunch of variety, and so you have to do some proper feature engineering. But beyond that, the rules of Go and all these tricks were not in AlphaZero, and it was able to perform just as well as AlphaGo. And but what they did have written in hand by hand is the game tree. So when they're doing this game tree search, they're still, the mechanics of Go are built into that. So in other words, AlphaZero will say, and this, now it's AlphaZero, so it works on many games. AlphaZero will say, take this move, this Go move, this checkers move, this chess move, and then that would go into some program that a person wrote that would make the move, adjust the game appropriately, tell them if they won or not, and then it would go, and then it would, and then that would conclude a simulation. So they would simulate using the hand coded engine. And after so many simulations, then they have a good action, right? So then they took it to the next level with MuZero, where in MuZero, they don't even use the rules of the game. And so, actually, in the neural network, it has to represent the rules of the game, and it actually has to do the simulation in the neural net. I think they're using like an LSTM or a transformer or something. And so, literally, they've gotten to a point now where you give it a Go board and it thinks for a while and it does all these simulations and it just comes back and it says, you know, place the stone here. And I feel like that they're starting to unpack that planning and that reasoning and that symbology. It's totally uninterpretable to us, but they're starting to unpack that process, which I think is really exciting.
Yeah, I mean, it's kind of like if you had a child, right, and you asked them to, like, you never told them how to play the game, but you just let them watch, a bunch of people play. Like, would they, like, how well would they do at understanding the rules, and could they construct that abstraction? That's probably, like, easier for some people, harder for others, but fundamentally possible, right? Like, we wouldn't see that as beyond us. I think it's interesting. Yeah, I think you're right. I think that is like I like the way you put that, kind of like what's fundamental about that advance. I think what it's important to remember too is that playing field, so to speak, or that area of board games like that is so ridiculously simpler than than any, like, sort of knowledge or human conversation or language based
Yep.
kind of real application that we have. I used to give these talks where I would talk about, like, okay, everybody who's kind of like who's learning a lot about machine learning, and I'm not trying to put you in this box, you just reference something in my mind, but everybody who's trying to first learn, or who kind of sort of first learns about how to get machine learning done in one context, rolls into the conversational context, and they have kind of the same idea, right? Which is, they're like, cool, I need a feedback loop here, right? Like, what I need is, like, somebody, person's talking to the computer, and, like, good thing happens or bad thing happens at the end, and then as soon as I have that, I'm gonna do this self-optimization thing, because that's how machine learning works. And there's a reason no systems work like that, in the world, right? There's there are pieces of systems that work like that in real applications, but there is no, like, end-to-end trained dialogue machine that's that means anything to any person, that's used for real applications, that is in that closed looped form. And it fundamentally comes down to how complex the space of language and dialogues really is. And even though the space of Go, from a mathematical perspective, is vastly complex, right? And 2 to the whatever 100 13 or 111 or how many points there are on the board, kind of combinations of stones and all this stuff. Like those are huge numbers. But when you start with language, you begin with what is literally mathematically an infinite dimensional vector space.
Yep. And the other part of it is there's no ambiguity in Go. I mean, you place the stone and the same thing happens every single time, and there's no room for interpretation. But for language, it's the exact opposite. I mean, you couldn't build a language that didn't rely on assumptions.
I mean, if you do, you kind of end up with something like a computer language, right?
Yeah, that's right. Yeah.
That's sort of where that goes in a lot of ways. And I mean, those are obviously meaningful and interesting, but like, nobody talks in Python for a reason.
Right. Except Patrick, but nobody else.
Yeah, well, that's actually interesting because it's another thing GPT is really good at. It's really good at writing computer code out of language, which I think is a fascinating
the Codex,
application.
Right? They're calling it Codex.
There's like a few different ways this has come to life. So there's a bunch of people that have done, like, you can go like poke through Twitter and find all sorts of good examples of, like, you can literally build a front end in some cases by telling the machine what you want the web page to look like.
Oh, I've seen those demos. They're amazing.
But to your other point, right? So sorry, we kind of meandered a bit, but to your other point around uncertainty, I also really, really agree with that. I think, and I think it's a big problem in conversational AI, right? Like, you have these models that are built on, especially natural language understanding, that are built on these transformers and these embedded representations, and they're, really good in a lot of ways. They're very smart, but they can make really dumb mistakes still, right? That's not beyond them. And so most industrial strength models, most real systems have some, sort of are forced to have some combination of rules and backstops against these, neural network approaches. And I think a lot of what's under that, or a lot of what's missing is, is there a system around that has a good idea about how good this natural language understanding system is likely to be at this problem? And my personal opinion, and some of the research work that we're doing, is that you actually need that system to be fairly decoupled from the system whose job it is to make the prediction in the first place. I think you can't have zero coupling, and the art of it is kind of like, in what way is, let's say, the natural language understanding understander decoupled, and in what ways is it coupled to the system itself? Like, that's kind of like the hairy edge of this problem. But I think we haven't done a great job at that yet. And I think there's a lot of research, not we personally, but like we as a culture. And I think there's a lot of research still to be done. And I think it'll be important because I think it'll foundationalize some of the other problems that you talked about, right? So if we want to start building a better hierarchy of understanding for some of these models, like, a step on the way there is to ask, like, well, when is it wrong? And, like, have a separate opinion about when these models are wrong, which can help us develop separate, like, an understanding of the categories of types of times when these models are wrong. So you can start to imagine an interplay, right? If I separate that system enough, it's going to begin to categorize, a whole slew of cases where this thing is wrong that it doesn't know about. And then those slew of cases become the basis for an abstraction of, okay, what's a knowledge center, that this thing, where this thing is weak.
Yep. Yeah, totally. Yeah, I think just as a field, handling uncertainty is very, very difficult right now with deep networks. I mean, there's and this is for something simple like a supervised model. Let's say the model that predicts cats and dogs or something. I mean, there's still not any consensus. I mean, there's effectively 2 or 3 camps. There's one camp that says, well, train 10 different models, either on 1/10 of the data, or you shuffle the data for each model, and then now you'll get 10 different answers. And so, depending on how much those answers vary, you can say how confident you are. There's another camp that is effectively doing the same thing, but within the model. So, you kind of multiply the layers, and now you have this distribution. And then there's this camp that says, let's put priors on everything and use kind of Bayesian approaches. And none of them work very well. I mean, the reason why we don't have, the reason why you can't just go on PyTorch.org or TensorFlow.com or whatever and just get a model with uncertainty is because there's not really a method that satisfies it very well.
There's a lot of reasons for that, but I think one of the most important ones is sort of broadly goes under the header of like processes that generate language and how varied they are, right? And so I think this is one of the things we see in an industrial context all the time, is that you can have models that are great and doing well, based on real live training data from real live people that really live talk to the model, and that you have now learned to correctly predict. And then think, something very subtle about the underlying environment can change. People can start talking about the business promotion in a different way because it's now there's an advertisement that describes it in a different way, and all of a sudden some of these things really start to fall apart. This is one of the areas that for me that illustrates like why NLU kind of isn't where we think it should be or where we think it is. And I think that mathematically what's going on into that is that there's the generating function for language and the infinite dimensionality of this vector space, right, are allow for, they make it very hard to train models that are really rooted in the semantics as much as we'd like, and probably in the same way that GPT is existing on this membrane and really only seeing what it can see and missing these big pieces of reality and not having some of this like base symbolism to attach to. The models that are doing the work of conversational AI today are still a little bit, they can be infected with problems like that, and they can be confused by what we call lexical cues more so than we'd like, right? So a lexical cue, for those who don't know, is just like something more on the surface of language about the word choice and the top level design of the words in the sentence, versus semantic, which is like, okay, what's that deeper, agreed upon meaning?
Yeah, I mean, one really prime example of that is cats and dogs, right? I think that we always hear that analogy, like it's raining cats and dogs, or this person's a dog lover, this person's a cat lover, and so our mental model, as a society, is that cats and dogs are opposite. And all of us, as a child, grew up watching movies where cats and dogs didn't like each other, right? I mean, that's a trope, right? And so in our mind, cats and dogs are really far apart. But if you were to use GPT-3, it's going to put them right next to each other. And the reason is websites that talk about cats, a lot of them talk about dogs too. I mean, imagine a website that sells pet food, right? I mean, they're going to be talking about cats and dogs at the same time. And so actually, when you look at anything unsupervised, it's going to put cats and dogs very close together, especially in the grand scheme of anything that could be talked about. But we have this sort of cultural separation, and those kind of things are just very hard to put into the model in any meaningful way.
Yeah, I mean, I think what you hope is that scenarios like that will be accomplished via like the high dimensionality of the embedding space, right? Like you can learn about some of that because on some dimensions, and high dimensionality is like really hard to visualize, as I'm sure you know, and really hard to have intuition about because the distance metrics and all this start to behave really weird. But you would hope that there'd be some dimensionality where there's like this separation, right? Which in our minds would correspond to like a character of the animal or something like that, rather than a functional a view of the system, right? Because we're also not surprised when we go into a pet store and we see cat food next to dog food, right? Like that doesn't make us say like what's wrong with this world, right? And that's so we can we have those like separate dimensions or something, so I think I would hope that the representations can accommodate that, but I think the challenge, to go back to the earlier point, is what are those underlying dimensions? They're not stable, right? Like if I slant a concept like slightly differently, we might redimensionalize that space a little bit differently, and so we sort of make them up on the fly in a lot of ways. Obviously there's some touchstones, but there's sort of something that we create dynamically. Like how do we interact with models at that level, through the training process or through the even a discursive process in dealing with them, which is another thing I really like about GPT-3, is that you now sort of talk to the model by giving it examples and can kind of train it with real language. That's also an advance I think is very important, and we're going to need to kind of cope with that and figure out how we use it, because ultimately the better these things are at creating abstractions and redimensionalizing what they're talking about in the ways that we're kind of discussing, the more we're going to need to converse with them to make sure we understand how their minds are working, in the same way that when you and I talk to each other, like we got to get to a baseline about like, is he is he actually a dog hater? Like I have to kind of figure that out first to talk to you appropriately about dogs or something.
Yeah, I wonder if someone, so if OpenAI is going to train a new GPT model, I wonder if they started with books for babies, and the random network was biased in favor of babies books, and then they literally trained it on books meant for older and older people. And so it kind of followed the same path as a human in terms of what kind of material they consume. I wonder like what that model would presuppose. I feel like there's something maybe really interesting there.
Yeah, I agree. I think you quickly end up in the world of AGI, right? It's artificial general intelligence, and that definitely by no means an expert there, but I think that's kind of where a lot of this stuff goes in the end. Is you're like, well, I have to start teaching these things more like they're a child, and I have to start relying. And again, this is why uncertainty is so important. I have to start relying on their own understanding of themselves and their ability to express their understanding of themselves in order to influence them in the ways that I want to, and have them take right actions. And so it sort of quickly starts to, if you really break it down, I think you start thinking like, wait a second, I've got to imagine this as a more like a human thing that I'm teaching and less like a mathematical process that I'm training. But obviously the math doesn't go away.
Right, right. So we'll dive into a little bit on transformers maybe, and then we can back out and look at the whole problem again. So if I remember correctly, my knowledge is very limited, but transformer somehow it can take in an arbitrary number of words, and then it creates some embedded space of that arbitrary, that variable length paragraph, I guess. And now then from that that's the encoder, and then from that embedded space you have a decoder that can emit words, and then also emit transformation to the space. So imagine like you have this embedding that contains all these things that you want to say, and as you say those things, you move to different points of the embedding where now there's less to say, and eventually you emit some special token that says I'm done. Is that, I mean, did I kind of get that right? Or like how do transformers work?
Yeah, I mean, I think it's an area that's live, right? There's definitely a lot going on there. So I guess like what I would reference, I think for folks, like one thing that I think is important is this notion of attention, right? So one of the hard problems in language for a long time has been like how well can a model like reference across a great degree of like space between concepts, right? And so when you look at a problem like, trying to think like a sequence problem, like a time series sequence, right? You one of the longstanding problems in time series analysis is like, well, what if I have an effect like last January and now it affects this March or something, right? And it's a
Mm-hmm.
macroeconomic underlying effect. And so there's been all this work in sort of hand curated feature building in those contexts, these are sequence models as well. So they're fundamentally kind of like mathematically the same type of object that you have when you analyze language. Um, I think there's a lot of bespoke techniques to do that in time series analysis, and all the ARIMA models, and they go just like tons and tons of work. And I think the same thing was done for many years, in a hand curated way when looking at language. And so I think one of the advances that's pretty important in this context is that we've begun to train these models and these transformer based systems in a way that they can locate those long associations, right, and in a way that they can provide for us. Uh, this is kind of another way to talk to the model, right? They can provide for us connections between them, right? You can ask, well, what other words in this sentence does this word relate to? And in an industrial context, that's super helpful because as a way of tuning and debugging and trying to improve systems, right? Those sort of like co-reference patterns. And I don't mean co-reference in the literal sense of co-reference of language, but these patterns of correlations or these patterns of mutual interest or mutual effect become ways to find to go and kind of ferret out the misunderstandings that the models are having and try to improve them.
Got it. Okay, cool. That makes sense. Yeah, I think I definitely have to get ramped up on it. My background's in reinforcement learning, and I saw a paper recently about someone using transformers to do sequential decision making. And so transformers are kind of coming into like a battering ram, just coming into my field and so many other fields. And so I have to definitely, I have a to do to get ramped up on them. But yeah, I think that I've had seen the word attention a lot. And yeah, maybe we'll get you back on and we could do a whole show on transformers, or we could somehow get ramped up on that. But yeah, let's pivot to LivePerson. So tell us about LivePerson and what you all do and what kind of services or products you provide.
Yeah. So, all right, live person. Fundamentally, what we're trying to do, we have some new things we're trying to do as well in terms of relating directly to customers. But the core business of live person for the last 20 years or so has been about essentially making the connection between us, the people in the world, and the brands we have to deal with or want to deal with a little bit better, and making our lives a little easier because of it. And so that began back in the day with online chat, right? Which is sort of almost a dirty word now, and I think we actually would say at LivePerson that we thought it was a kind of a dirtier word first, right? Not that online chat doesn't have useful applications, and we still do a lot of online chat, but we don't see it as the future of like, hey, I log into a website and I have a sort of not persistent or like a liminal connection with an agent on the other side, and I'm chatting with them for 5 minutes, and then if I break the connection and it's gone and I have to start again. We don't see that as like a model for a really good customer experience, or a really good brand experience for that matter. So, but that is kind of nonetheless like how the company was built, because that model does have some advantages over just the straight phone model that was what was there before. But as time has gone on, right, and I guess it's about 4 years ago now, maybe 5, LivePerson went early, into a messaging context and what we call more asynchronous communication, right? So now you've got brands and consumers communicating through SMS messages, through WhatsApp, through Line in Japan, through whatever, right? There's a sort of umpteen messaging platforms out there. And one of the things we do is we make sure that you can hold a great conversation with your customers on these platforms. But where that obviously starts to lead, and it's really interesting when you look at the conversations people want to have and what it means to shop that way compared to what it means to shop in kind of the web signature way that we shop today, or the website context, the way that we shop today. It's fascinating, right? And one of the things, the jokes I sometimes make is like, one of my interview questions at Amazon was like, all right, well, help me build a model about whether or not this shopper is about to leave the website, or help me build a model as whether or not this is a gift shop, or how would you build that, right? And these are things that people just tell you in a conversational context because they're trying to get help, right? So one of my favorites is a woman talking to a sporting goods company, and she's like, hey, I'm late gift shopping for my 12 grandkids and my 6 great grandkids. Like, can you please help me find some gifts for them? Right. These, literally like the kinds of things that a company like an Amazon would be like, sifting through web search and web activity history to try and make an inference about, are just things that people they want to let you know that this is their problem. They want you to give them help in solving it. She was very interested in the fact that this service agent on the end of the line could, next year reach out ahead of time with some proactive offers, right? Like all this stuff that can kind of feel seedy if a company's doing it behind the scenes on a website, but feels very natural if you're the one telling the company, this is my problem and I'd like you to help me.
Yeah, that makes sense.
Yeah, so this, like, when I kind of drink the Kool-Aid on this problem, and sometimes I drink the Kool-Aid, I feel like what we're building is a way to do a more open and transparent and a little bit better and warmer conversational experience for shopping, which takes you back to the world that we all used to live in kind of before the internet, where most of shopping was like that.
Yeah, I think that to your point, I've recently been buying all my clothes online since COVID. Once you've narrowed down the size, and almost everything comes in almost every size. So narrowing down the size doesn't really do anything. It's almost like how do you sort of search for your aesthetic? It's really difficult.
Yeah.
But I think that if it was sequential, Like maybe I would search for blue shirt and I would look at what came back and I would realize, okay, really what I need is a blue striped shirt. And somehow knowing that this person pivoted to blue striped shirt, that now it's like, okay, you have these two things, and maybe you would show a striped shirt that's navy because that stripe part is really important. And so just handling that modality, I think, is a conversation. And whether you're doing it through a search engine or you're doing it with text generation, I think that's something that has to be addressed.
Well, and if you think about it, like what you really want to understand, if you're in that conversation with someone and trying to help them buy a shirt, is something a little more fundamental about what they're doing, right? Like, are we in a situation here? I don't know how you shop, but like, I might be in a situation where I've already had 3 copies of this basic shirt, and I'm trying to find it in a different color, and I know it fits well, and I kind of just want to get moving and like go get myself a 4th one because I love these shirts. Like, it's a pretty uncomplicated mission, and what I want in that situation is someone to show me all the different copies of that particular item, and then maybe I want a little back and forth on the style I'm looking for, and I'm done. Or I maybe like have been like poking around the internet. I'm like, I need a little bit of a fashion change. Like, I feel like I'm kind of boring right now, and I'm looking for new ideas, and I'm looking for a shirt that like maybe I wouldn't have worn before, and I might need a little I might need a really different experience.
Maybe I'm teaching 7th grade and I need a periodic table that's somehow also like WWF.
Right. I need this SmackDown. Like, I need to turn it over, and then Macho
Yeah.
Man Randy Savage can jump out of it or something.
Yeah, like a hydrogen atom and just crush it.
Yeah, exactly. So, like, I think you want those. You want those missions underneath. This is a lot of like where the through line for at least my career sort of matches between Amazon and Nike and LivePerson. It's like, what are those missions and how do you define them? And I think the language context is obviously the best context to define them in. A lot of what we build is about allowing brands to sense that and to identify those missions from the language that their customers give them so that they can be more helpful. And so this, when we talk about conversational AI, or at least the tools of conversational AI and how we use them at LivePerson, there's at least kind of 2 big categories, right? One category is around, of course, like helping brands build these systems so that they can, have automated ways for customers to solve their problems so that it's easier and faster and better for everyone. And then the other side is like, okay, well, how do you are you set up to really listen to your customers? Do you know, for instance, that when, your customer complains about having tried to call you, having tried to reach you on your website, and having tried to, to text message with you, by the time they're at that point, they've got like an 80% chance that they're going to leave you because there's this canonical problem that just frankly makes everybody mad. And so being able to listen to stuff like that at scale, right, and understand that at scale so that you can provide a better customer experience, like that's another sort of layer of the conversational AI offering that's we think is really important for us and really important for brands. Because in the end, like, consumers in America and other places now, we're pretty fickle beasts, right? Like, we've been kind of trained by like the Amazons of the world and other companies that have pioneered in customer service, to create like these really positive service experiences for us that they're really different than 30 years ago, right? But now that's the norm. Like, and if you want to keep building your customer base, if you don't have a captive audience, if you're not like a cable company or something where like nobody can leave you, then you have to be great at this now, and you have to kind of blur that line between what are you, how are you solving their problems, and then how does that translate into future growth between you and them and building that strong relationship. So we kind of build products on both sides of that, right? We build natural language understanding with both of those use cases in mind, for instance.
It sounds like another part on the product side, though, I think would be really tricky would be knowing when to hand off to a real person. That seems like something that a lot of companies, wouldn't know how to do. They would really rely on you for that.
Yeah, that's right. And I think like that's actually like a nook in a much bigger problem, which is how do I understand how well this system is doing with my customers? How do I understand the quality of these conversations between the computer and the person? And there is not good tooling for that. This is one of these like foundational areas where I think, you just don't find anything good in the industry right now, because it's one of these annoyingly hard problems, right? And it's kind of related to all the abstract stuff we've been talking about, like when does a model know it's doing well, when does it not, and like how deep an understanding and how introspective is that model in the first place? And the answer is typically not very. So so you can't rely on the model to do it. You need to kind of build some of these these separate systems to be able to see this. And some of that requires like really rolling up your sleeves and doing some dirty work and being like, what are like the top 10, kind of like, what's the right way to describe like the top 10 kinds of problems that people face when they're trying to talk to automated systems, and how they break down and how that customer experience goes wrong. So we spent a lot of time on that. We have products, that we're bringing to market right now. In fact, on measurement, the product has this pithy name of MAX, right, which is the Meaningful Automated Connection Score,
Nice.
which is really about like, hey, how good or bad was your CX in these automated conversations, and like where should you improve it? It's important for two reasons, right? One, you need to know how well you're doing in order to have any sensible business strategy, and two, tuning and optimizing these AI systems is like really hard. I shouldn't say it's really hard. It's a lot more work and ongoing work than people at first often conceptualize that it's going to
That's
be.
right.
Right? You got to think of it like if you're building a website, you don't build it on a Thursday, send it live, and then don't touch it for a year, right? Like you would never do that. But a lot of people think about conversational. Oh, I'll build the bot, I won't touch it, it's done. But it's an ongoing process of iteration, and we need better tools to, in the same way we do website A/B testing, in the same way that we have a bunch of tagging and and kind of infrastructure and software built up around learning what's working about your web presence and improving it. We need the same thing. You need the same things if you're going to learn about how to improve your conversational AI, and that's part of what this metric and the system is about. Is helping you quickly locate places where the conversations got wrong. Where did the bot get stuck in a circle, which drives us all crazy? Where did the NLU just like totally get, just like totally barf and lose it, and like and just like completely break the customer trust, right? So we're like, our play in general has really been about quality. And one of the obviously one of the most critical pieces of quality is like, do you really have good measurement? Do you have good understanding about what quality is, and do you have good pointers as to where quality went wrong?
Yeah, I mean, this is a huge, huge problem. I think the people who, if someone can even crack this in a generic way, it would move the entire industry a mile forward. Because I think we have all the same issues where it's just so hard to triage one of these situations. And what we end up doing, you're probably doing something similar, is just coming up with so many metrics on, for example, how many people are clicking on this, like what's the click rate, let's use Amazon example, what's the click rate, what's the conversion rate, how many people abandon the whole site, how many people bounce, all of that stuff. And then you have this downstream problem where as soon as you define a metric, you create an incentive. And so people, machine learning engineers at your company are going to try to drive that metric up. And so typically what happens is eventually something that's not being recorded will start to suffer, right? And so now you have to make a metric to track that. And so you end up like just adding more and more balls in the air. And it's because you're in this arms race with yourself, right? And so it's just so difficult to go through that process.
It's a little bit of like a metrics alphabet soup in some ways. One of the things we did to deal with that, the first thing we did before we started kind of working on this Max project, was we sat down and said like, well, we need to organize like this system, like we need to organize the metrics somehow, because people are doing exactly what you're saying. And like a conversation I probably had 5 times now is before the pandemic, I would go physically to brands all the time, and now I talk to them on the phone. But they, I'd sit down and be like, okay, well, how's it going? They're like, oh yeah, we built this bot, and it's whatever platform they built it on. And they're like, it's great. It's got an 80% containment rate. It's awesome. I'm like, that's great. Like, what are you doing with the 80% extra capacity you now have in the human contact center? Like, what did you choose to do with all those people? You must have like people at their desk with nothing to do, right? And the answer is never like, oh yeah, like here's what we did with them. The answer is always like, well, no, actually volumes in the human side have actually gone up, or they've basically stayed the same, but the bot's doing great, right? And it's fundamentally because this concept of a containment is just a very broken way to think about whether or not the bot served the person in the way that it needed, it solved the problem or not. So like I said, one of the things we did was we sat down, we said, well, let's organize the metrics into some conceptual framework that people can use so that they can see, because we're not going to get out of this. Like, there's not going to be one magic number that does everything. This is actually a highly multivariate problem. There's lots of different ways to think about what good means.
And people are adapting. As soon as you make a metric, someone will try to game it, and then they'll cause another problem.
Right. So you can't like kind of live on that one. It's too unstable.
Yep.
So we built this framework, so we gave it the pithy name of the 4 E's, right? And there's an efficiency vector of metrics. There's a, effectiveness in solving the customer problem vector of metrics. There's an emotion, right? Was the customer's emotional response? And now I'm going to like totally blank on the 4th E, which is going to make me super embarrassed. It'll come to me in a minute. Anyway, so we've split into these categories, and under them we put both sort of existing contact center metrics that people are used to, like repeat contact rate within an hour, within 3 hours, within a day, and then some of these newer metrics like, hey, what's the max CX on this, or what's the sentiment of the customer, and as measured by these machine learning models. Right now, you can begin to give brands a sort of reasonable target to optimize for that makes conceptual sense to them. The 4th E, by the way, was effort, right? How much work did it take to solve this problem? And that's really, these are like much more connected to things that we care about as customers. Like, when I tried to contact you, did it work or not? That's effectiveness. Like, how much of a pain and frustrating was it? That's emotion. How much work did I actually have to go through to do it? That's my effort, right? So those correlate, and these concepts I think correlate a lot better to what a great CX is. So we spent a lot of time on that. And then that set up, again, like some of the max work and some of the analytics work that we've done subsequently as well.
Very cool. Very cool. So what is something that makes, and I know with COVID, we're all working from home. And so everyone's job looks pretty much the same. There's kids running around, and there's a dog, and there's, but like before COVID, or maybe projecting into the future, what about LivePerson is really unique, or you kind of walk into the office, or maybe you talk to the folks and you feel like this is something I haven't really seen anywhere else?
Yeah, you mean like in terms of being inside the company, or in terms of what the product offers?
It could be, I know this is inside the company. So it could be, everyone plays ping pong on Thursdays, or it could be something about the nature of the kind of ethos that you've built, something like that.
Yeah. So for me, I mean, I don't know. You probably have to bring people on the team to make sure I'm not lying to you. But I can tell you about what some of the things we strive to do, and some of the things that I see as successful at. I don't think it's easy. I guess let me talk about the science domain. Like, I don't think it's easy to have to combine two critical concepts that are important for real success in like scientific research and product development. And those two concepts are, one, like the truth seeking. Are you really satisfied with what you've done, or could it be better? Or what's really wrong here? Those kinds of questions. And then two, like a spirit of real collaboration and support. Right. So oftentimes, like when I was a physicist, right, like the way that physics solves this problem is by not solving it. They just go after option one. And, it's not at all uncommon for the chief like discourse between two physicists to begin with, like, for somebody to start out with, well, that's great what you said, but let me tell you all the ways in which you are an idiot. Right. Like literally,
We have a term for that. We call that the intelligent jerk.
Yeah.
It's an archetype, an anti-hero of the tech world.
Yeah. And I mean, it's very common, and like there's a sense to it logically. Like, if you don't have some of that disagreeableness, and I mean that like literally in the psychological sense, you run into like too much conformity and you don't do great work, right? Like you can't actually do well without some degree of that. But like, to find a group of people that can marry that and can have that same impulse and understand how to express it in a way that is constructive, right, rather than destructive, and like builds partnership rather than tearing it down. Those are special people, and we work very hard to really staff ourselves with that combination of skills, like up and down the science org. And I'm pretty pleased with how we've done. I think it's one of my, it's without a doubt my favorite place to go to work and do science work and learn about, research that I've ever had. And I had good situations at Amazon, a good situation at Nike. I'm not saying they were bad. They were great. But I think we've done something special by prioritizing, that combination. We have not hired great people that we felt like just weren't going to hit dimension 2 very well.
Yep. Yeah, it's a really good point. Because the other thing too is people who are really good, and have the right, emotional quotient and have that ethic and have all those pieces, they're going to grow really quickly. And people who go quickly, you know, I don't know what data there is on this, but people who go quickly will maybe want to change teams because there's an opportunity somewhere else, or change companies or something like that. But people who are in over their head, or who don't have the right character, those tend to be the people who stay forever. And then so it's like, it's so difficult to, I mean, so much time needs to be spent to get that right, because
Yeah.
otherwise, there could be whole years where there's problems that take a very long time to sort out.
Yeah, I think there's some dynamics like you're talking about that are very real. I felt like I think one partial antidote to at least the first part. I don't have a good antidote to the second one, but I think one thing we're also really fortunate about at LivePerson is we have pretty amazing data and capabilities to work with, right? There's hundreds of millions of goal-oriented dialogues coming through the platform every day. Obviously, we use those thoughtfully, carefully, and respecting all the contractual arrangements we make. We don't use all those conversations the same way, but different brands have different expectations about how we use that data. But nonetheless, like, there's lots and lots of amazing conversations to work with. And there's also tens of thousands of people sitting on the platform who can inform conversational AI with their opinions and their expert opinions, right? All these agents sitting there, able to give feedback to the systems and tell them when they're working well and when they're not. And so some of those tools, I think, like, fuel, much more so than anything that I or the other managers on the team do every day, fuel like people coming and really kind of hunkering down with LivePerson and doing good work for a long time. So it's been nice to experience that. But yeah, in general, I agree with your assessment of the dynamics. Like, you get somebody who's struggling on one of these two dimensions of work, and it's hard for them to leave because it's like there's a lot more risk for them.
Yep. So for folks who are listening to this and completely enamored, they want to do conversational AI, they want to get into this field. Does LivePerson have any openings? And can you kind of break it down into, does LivePerson have internships? Do you have full-time positions? And if there are, post COVID, if there are geographic locations you want to focus on, what are those?
Sure. So the first answer, or the first thing to say, is we're hiring a lot. Like, the company's grown. You go read our public record reports. We are a public company, so you can see how we're doing, and we're growing rapidly. So we have a lot to do. This year I'm really trying to focus on building an exceptional scientific research team that's going to look farther afield in time, right? So we've typically had at LivePerson a strategy of, well, like, we want to work on research, we want to work on science, but we want it to be in the context of being productizable in the near to medium term. So really not much more than 6 months out, we want to see this come to life in a way that impacts the product. And I think that was right for where we were and all the stuff we needed to build. There was a lot of obvious stuff to do. But now we're in a different place, and I think we want to be looking on 1, 2, 3, 4-year timeframes for how some of this stuff turns into technology that we can use, and we want to go a little deeper with academic partnerships as well. So I'm staffing just a full team on research with kind of that mandate, looking for a lead for that, who wants to come in and say, okay, I see this data you got. I understand you guys have a basic dialogue problem you're trying to solve, and I want to go push science research in this direction in partnership with this academic institution over the next 3-4 years, and here's the agenda, and is going to help drive that. And I mean, I have some ideas about where that should go, but I'm really looking for a very senior lead to come in and take the reins on that. So we're actively recruiting there, and they of course will actively recruit for the team that works with them. But we have other jobs and other opportunities as well. LivePerson's an engineering company. On my team, I hire analysts as well. We do, like, I run a lot of the analytics products for LivePerson, and we hire, of course, machine learning engineers. We hire people to build backend systems that are supporting all the model building and the model training and the model management. And we're doing a bunch of work of migrating pieces of the platform into the cloud, and so there's a lot of, like, real engineering work. So one vector that often works well is for if someone has a strong engineering background and they're interested in this space, right? There is there's definitely work to do to become an expert in the science and the field, but there are ways in, I think, there's a lot of engineering work that provides, like, a boots on the ground a kind of introduction to the technology stack and kind of get you, and then you kind of get into the flow where we're now like, okay, you're coming to our Friday brown bags, you're working closely with the scientists because you're building things that they're using, and so you're in conversations with them in a different way. It's a really live place to learn and grow. So I mean, I would come, if I were someone with a strong engineering background who was looking to get into this field, I'd be looking for a way to do it with a role like that, rather than trying to say, like, well, okay, I'm going to go to boot camp for 6 weeks. I'm going to read a bunch of papers. I'm going to do some, prototype like chatbots, and then I'm going to be ready to do a research role tomorrow. I think, maybe there are some people out there that are just like astoundingly fast learners, and that will work. But I think for most of us regular humans, you want to
Yep.
you want to find a way, like, I'm going to build this into my life for a couple of years.
Yep. And there's so much tribal knowledge, that, I mean, it's that boot camp doesn't exist where you're going to learn the tribal knowledge to be able to ace a research scientist interview. So yeah, I think your advice is spot on.
Yeah, and I mean, in addition to acing the interview, even if you can, like, and you show up on day one, like, are you ready to do the job, or are you setting yourself up to succeed, right?
Yep. Yep. Do you have internships? You have a lot of folks who are maybe in the middle of their college and they're looking for something over the summer, but then they're going to go back to college afterwards. Does that exist?
Yeah. In fact, we just set up a meeting, I think, for next week to sit down and talk about how we're approaching next year's crop of internships and what we want to
Cool.
do there. So yeah, we will be doing internships, and we do them all year. We have interns right now, and for different disciplines and different times makes sense, right? But there are a lot in the summer, and we've been focusing a little bit on some of the graduate students, the last year or two. So it's been mostly PhD or master's degree students who are coming in and doing internships. But I think we're going to change that this year and have, a little bit more undergrad work to be done. The team's gotten a lot bigger. And one thing that means is that there's, a wider variety of like types of work that needs doing. And I think we have some spots for a really good undergrad research project or two that look pretty interesting. Like I said, we're kind of still in the middle of figuring it out, but that's basically where we're headed. And for me, I like to make sure that, hey, if we're going to put an internship together, we want it to be something that's like a little risky, right? It's a great time to take a risk, but also something where we see like a legitimate chance for success, and like we're gonna learn something either way, and everyone's gonna benefit from it. So I think we'll be in a position to do that with undergrads next year. We're definitely continuously in a position to do that with grad students. That's not going to change. So we'd love to hear from people who are interested in, possibly joining us in that way.
Cool. Excellent. And so if folks want to check out LivePerson, you go to liveperson.com and you can see what they're all about. And if you want to reach Joe, you could reach Joe at jbradley@liveperson.com. And you can shoot him. I'm sure you can shoot him a resume. He'll forward it to the right folks, or there's probably a place on LivePerson where there's like a careers page or something like that where you can
definitely apply online. You can definitely reach
Yep.
out to me too if you want to say hey, and would love to hear from the audience here. As I mentioned before we get started, like, I think you guys do a pretty cool podcast here. I like how application focused it is, and it feels like it has a lot of weight to it. So I'm sure your listenership are all pretty cool people.
Yeah, definitely. And they're super motivated. We've actually connected a lot of interns to careers, to at least to internships. And so, and we're constantly getting emails. The show's been out for a while, so we're constantly getting emails from folks who have landed full-time jobs or even been in them for several years, and that's really special. So I feel good about. I think there's going to be people out there who are a great match for LivePerson. And now, if you're listening to this, you're one of those matches. Check out the show notes, check out the website, and get connected. It sounds really. Oh, actually, so we didn't cover location. So where is LivePerson based?
Yeah, we're a distributed company now. It's evolving, like I think a lot of companies are. But when the pandemic started, we wanted to give certainty to everyone early on. And so, we said, hey, if you want to move where you want to move, go move, right? Like, as long as you can do your job, right? As long as it doesn't impact your work, we're pretty open. And we're not sort of demanding people be ready for a mass return or anything like that, because we wanted people to live their lives. now that we're coming out of the pandemic, I think we're hopefully coming out. I guess we're resurging a little bit. But as we sort of take steps out, we are beginning to open physical offices again. We have an office open in Seattle here that I've been to. We do COVID testing either the morning before you come in, or you go do it at the office before you come in. We're obviously following all the policies and protocols that that are local to the areas, and we have our own sort of standards on top of that. So I think we will be coming back more and more physically. We're probably going to maintain a high degree of flexibility about where people work and how that comes to life. We have some policies and standards around how to manage the pay scales and things that you sort of have to do from a corporate sense for the economics to make sense. But I think we've done that in a fair way, and I think we're open-minded, and particularly when it comes to great science professionals and researchers and folks with a lot of machine learning engineering expertise, and those people that are really doing great in these very hot fields. Like, these are the kinds of people we want to be really flexible with. Like, we think the most important thing is for you to come and work with us and for us to get some good work done together, and the exact details about the location and all that are pretty secondary.
Yep, totally makes sense. Yeah, I think it's consistent with where everyone's at, and I'm hoping they come up with some nice whiteboarding tool. I mean, that is really what, as scientists, this is the thing we need, is some way to whiteboard together.
Yeah, we're looking at that right now. We've got a couple of options that I want to get put in the office and try out to see how they work. I don't know if they're any good yet or not, and we haven't really tried out the tech, but I kind of agree. Like, I'd love to be sitting here and have a whiteboard here that I can write on, and that the writing of my my partner on the other end of the communication appears, and it's almost as if they were here. Like, somebody solves that, they'll be billionaires overnight.
Yeah, I wonder if, in general, the VR headset is never going to be so convenient that I would wear it all day. But I wonder if maybe that's, everyone keeps talking about the metaverse. I have no idea what the metaverse is. I'm assuming it's connected to VR, but that might be something where we could go into VR for an hour, and then there could be some holodeck like thing, and then somehow at the end it would accumulate a whole bunch of notes.
Yeah. I think it'll be interesting to see how we solve these problems. They're much bigger problems now, or more important problems now than they were a couple of years ago. Yeah, I wonder about VR too. I guess the metaverse is what the old Neil Stephenson reference from Snow Crash or something, which is.
Oh, that's right. Oh, it's been so long. I think I had to read that in high school. It's been a long time since I should give it a reread.
It's one of the only sci-fi books I know of where the 3-ring binder appears in a starring role, at least for the first part of it.
Yeah, that's right.
It's been a while though.
Yeah, that's where I think they were able to. I think it's like a murder mystery or something, or so. At some point, I think somebody dies.
Yeah,
They're somehow killed in VR. I mean, it's I have very, very not lucid at all memories of that book.
Language is a virus, right? Is this whole concept he's exploring, and I think there's this capability to you can show people information, and it infects them and gets them sick if you show it to them in the metaverse or whatever. It's been a while for me too, but I think it's something like that.
Yeah, we should make that book of the show next time, which means we need to read it again. Yeah.
Yeah, that'd be fun. If you guys ever want to do a Stevenson Fest or something, I'd be happy to come back.
Oh, cool. All right, we might take you up on that. Cool, Joe. Thank you so much. I know we're over time by a lot, but I really appreciate you spending the extra time and chatting with us. It's been absolutely amazing, and it's been a real pleasure. Thank you so much.
Yeah, the feeling's mutual is a super fun conversation. Thank you so much for giving me the opportunity to come on and chat with you guys. Very much appreciated, and I love the depth and the quality of the discussion. So thank you so much for facilitating that.
Cool. And thanks for everyone out there. I think you continue to support us on Patreon and on Audible, and we really appreciate that. I've been trying to post a bit more on Twitter. Yeah, in the past, I've mainly used Twitter to send show notes, but I'm trying to put some more content on there. If I see something that I think is pretty cool, and related to coding and tech, I've been trying to share more content there. So follow us on Twitter. Follow us on all the other ones as well, LinkedIn and Facebook. Any of those we'll definitely be posting the show notes there every time as they come out. And subscribe. We can, if we're not on a streaming platform at this point, let us know. I think enough people have let us know about enough platforms that we're on all of them, but there's new ones coming out all the time. So definitely keep us up to date. Keep us honest if there's something we're not on. And we'll catch everyone in 2 weeks. Thank you so much.
Music by Eric Barndollar.
Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.